this video too for today. We looked at it in the first video. I didn't officially define it. A similarity ratio is the ratio of lengths of corresponding sides. And if you remember the examples from video one, I think we had two that the similarity ratio was actually two. I just called it ratio. It's actually officially called a similarity ratio. Now, you do have a little bit of freedom to compare how you want. You could compare small triangle to big or big triangle to small. And they describe that in this statement right here. So this one would be a small side or small triangle to big triangle. So your similarity ratio would be 3:6, which reduces to 1:2. If you went big to small, it'd be 6:3 or 2:1. Both are correct answers as far as how you compare similarity ratios. Make sure this statement right here just says make sure that corresponding angles and corresponding sides are in the right order when you write the similarity statement. Okay, so here we go. This is a big part. The important part of this video is determining whether they're similar and identifying similar polygons. Determine whether polygons are similar. So write the similarity ratio and a similarity statement. Okay, and so these are both rectangles. Okay, and so the first thing you have to do is talk about angles. Okay, so they're all the same, right? So angle A is congruent to each of its corresponding angle in the other rectangle. So let's go around this way. So angle A would be congruent to angle E. This would be F, this would be G, and this would be H. Now, what about sides? Because you have to do angles and sides. Angles are the same, sides are in proportion. So AB for the rectangle on the left, I think it's going to correspond to FE in the one on the right. And then we'll just go around this, BC and FG. I got to make four. We may run out of room here. GH, CD, and then AD and HE. Are those in the same proportion? So let's check. AB over FE, 6/4. 9/6. It's a rectangle, right? So we know this is 6, this is 4, this is 9, this is 6. Okay, so keep going around this thing. 6/4, and the last one is 9/6. So those all reduce to the same value? Now, if you don't like fractions, you can use a calculator. Fractions don't bother me. This reduces to 3/2. In fact, they all reduce to 3/2. Okay, and it says, so I'm saying yes, they are similar. And here's the similarity statement. I almost put triangle, didn't I? Rectangle, ABCD is similar to rectangle, EFGH. Show the angles, show the sides. You have to do both. Determine whether these are similar. So write the similarity ratio and a similarity statement. Okay, so PQR and STW. Let's see. We know that these are isosceles triangles. So I know the angles opposite those triangles are congruent. This is an isosceles triangle too, so these are congruent. So that angle right there is 62 degrees. This one I got to do a little bit more work. I'm going to subtract 36 from 180, and I get 144. I'm going to divide that by 2, and I get 72 degrees. So each of these are 72 degrees. These are 62. I could figure out this third angle, but there's no way all three angles of this triangle, sorry for the bell, are going to be congruent to all three angles of that triangle. So not similar. Done. Okay, determine whether these are similar. Now here's what I notice. The angles and the sides. I have angle M is congruent to angle N. I have angle L is congruent to angle P. And therefore, these last angles would have to be congruent because we have that third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, their third angles have to be congruent. Angle J is congruent to angle S, I think is the last one that I said. Now let's check the sides. Okay, so small side is JM. Small side over here is NS. Middle side would be LM. Middle side would be PN. Larger side, LJ. Larger side, PS. Okay, so JM is 45 over NS, which is 18. LM is 60 over PN, which is 24. And then LJ is 75 over PS, which is 30. Now, here's where you kind of have your options. You can reduce the fractions, or you can just use a calculator. Hang on a sec while I get a calculator. All right, I'm back. So we're going to do 45 divided by 18. Come on, 8. Now, if you see it very well, I get 2.5 for this one. I wonder if I get 2.5 for all of them. 60 divided by 24, 2.5. 75 divided by 30, 2.5. I get the same similarity ratio, and that's my similarity ratio for all three triangles. So my similarity statement is triangle MLJ, or I'll just do this one up here. JLM is similar to triangle NPS. And there it is. Thanks for watching.